Okay, well, I'm Ted Klein, and somehow Rich put me in charge. He's busy with grandkids, and that takes priority somehow. So we're glad that you're all here. Thanks for being on time. Uh, we delay a little bit just to make sure everyone sneaks in here. Uh, Delighted. Let me first go straight to Tom, if I may, our treasurer. What's the news, Tom? What should we know about with Sarah? Oh, and then he went blank. Oh, there he is.
Oh, nope, I'm coming back. I'm here. I was just grabbing up a different window for something else. But we have money. I'm not actively acting as treasurer right now. As you can see, there's some stuff missing here, and that's because I'm saving money on haircuts and shampoo, but I'm spending lots of money on other chemicals which are causing my hair to fall out, or most of it's fallen out. Also, this is more than 4 weeks of stubble, and I'm just amazed by how little it's growing. But we have money, and there are renewals occurring, but we need to talk to Dennis. Dennis has picked up in my uh, problems, so yes, I will. I will. Hopefully, Dennis will show up, and he can give you a more accurate report on just what our conditions are.
Very good. Thank you, Tom. Good luck with all the experimentation you're doing. I've gone through a similar process and have come out the other side. Good luck. Um, Thank you for all you've done as well. We're going to find Dennis. Uh, I think we have Dennis Hoofnagel, but I'm thinking that's the wrong Dennis, right?
No, that's the wrong Dennis. We want Dennis Farr.
All right. Dennis is not raising his hand and volunteering there on that part. So good. All right.
Well,
Um,
I don't even see him amongst the attendees right now, but
Right. So we'll keep looking.
so he
Thank
may
you,
get permission.
Dennis, and thank you, Tom. Great. What we do is try to get together here, I guess twice a month, if not three times, if we count Australia, uh, and talk all about our favorite hobby of listening to the sky. I'm going to start working around to accommodate those folks with very late time zones. Today is when the USA changed time zones early this morning, and so I'm sure we'll be all confused here in the USA. I'd like to start with Dmitri if I could, and then Wolfgang, and then Eduard, and then we'll have others show up. Dmitri, tell us what's going on in your world.
Thank you, Ted. Uh, my greetings for all. I have uh, uh, today have some results of um, red giant observations on 20-meter dish in Green Bank. Just a moment. Uh, okay. Uh, uh, sorry, I would repeat some things I told already in previous meetings. Uh, this is continued work uh, of hunting uh, uh, main lines of hydroxyl infrared stars. Uh, the stars are in the end of their life, uh, and uh, they usually uh, uh, they usually will radiate in infrareds and too many dust and gas around the star. The dust absorbs the light, visual light, but you can see these stars in infrared and radio emission. Many of the stars radiate in hydroxyl lines in L band, which you can see in by 20-meter dish. Uh, the Green Bank telescope with L-band receiver. Have two peak measure and molecular spectrum in 1612 megahertz line. You can see the sample of such a spectrum, but sometimes other lines, usually called main lines, 60, 65, 60, 67 megahertz, also can appear in the stars, but many depends of how how quickly the stars losing their mass characterized by mass loss rate. Uh, Also, I have some characterization of the stars, this ratio of mass loss rate to square root of stellar radius. This indicator of envelope density around the stars. 20-meter dish rolled by Skynet system. Beam was about 1.6 degrees. And calibrated with system temperature about 60 kelvins. This year I have observed Canis majoris red supergiant with two line spectra about 10 in minus 10 in natural units. Observations was made this year in May. And also it have this Canis majoris have main lines. I just told that they called main lines because this line is usually observed in star forming region where conditions for exciting of this line is better for uh, than for red supergiants. But Canis majoris will emit these lines due to special conditions in the envelope. Also, I've told about observation of IRS 17411 minus 3152. Uh, uh, the star have a bit have lower density indicator, and his spectrum is in 1612 megahertz and 67 megahertz. Almost differs in levels, but the stars have the spectrum are similar in shape for both lines. This is second star in my collection of red supergiants with irradiation in main line. Next Iris 17004 minus 41 90. Very high density indicator, even higher than for Canis majoris. but 67 megahertz line was observed in 90s, but I observe only 6012 megahertz line and no even traces of 6067 megahertz. It can be due to the star variability. New fresh observations. First, V669 case. This is definitely hydroxyl infrared star, asymptotic giant branch star. This data initial mass up to 5 solar mass and current mass is about 1 solar mass. Moderate mass loss rate and a bit and density indicator a bit lower than for Canis majoris. You can see previous observed by Wolfgang in astropillar spectrum for 612 megahertz and 1667 megahertz line to peak usual to peak spectrum in 6012 megahertz and only one peak in 6067 megahertz. And my just a moment. This data is from review made by Chat GPT. Sometimes Chat GPT gives very nice review. This is review for V669 case. And you can ask ChatGPT for similar review, but it need some consecutive questions for to get to get to get well to get acceptable review. A lot of information ChatGPT can collect in the review, including pulsation period, mass loss rate, and ChatGPT can make some if some information is not found, it can get it can make some estimations using typical characteristic of red supergiant stars. And references from journals ChatGPT includes in its review. My observations for V669 case expected 1612 megahertz line with 2 peaks and one peak for 1667 megahertz line, a bit levels a bit higher than obtained by Wolfgang in astropillar, but almost coincide with his results. The shape and velocity of 1667 megahertz line is so it's similar to a lower peak in redshifted peak in 1612 megahertz line, but maybe 1667 megahertz spectrum uh, replicate uh, 1612 megahertz spectrum, but line in about 65 minus 65 kilometer per second, maybe just not detected. But one line is observed well in 67 megahertz. Uh, next next observation is IRS 07399 minus 1435. Uh, this is also red giant AGB star, AGB stars in very late stage of evolutions, and the star have begun forming its protoplanetary nebula, and this nebula is seen uh, by visual and infrared telescopes. It's sometimes it's called rotten egg nebula because this nebula uh, because this nebula contains many lines of sulfur and including hydrogen sulfide lines, and gas of hydrogen sulfide smells like like a rotten egg. Estimations by ChatGPT for mass loss rate is very wide because of exhibit uh, very strong super wind eruption events and very high mass loss rate, about in maximum about 10 minus 2 solar mass in a year. Estimations also by ChatGPT for uh, density indicator shows up to very huge 10 in -8 in natural units for density indicator. Uh, Interesting for the star that its peak the 6012 megahertz peaks is weaker than 6067 megahertz peak. You can see on this picture 6067 and 1612 megahertz peak peaks observations in 90s. You can see photo of this rotten egg nebula by Hubble telescope, and some from review from ChatGPT. ChatGPT, I didn't say it. I didn't told this is a star, not single star. This is binary system from one is with old star, and second star is companion is A type main sequence stars. It's relatively young star in in the middle of its life, and I think this mass can be specified by but ChatGPT can correspond only to and ChatGPT doesn't mention that this is why I don't know. But other descriptions is from ChatGPT is very satisfactory. And just a moment. Second, ChatGPT said that the star have strong 1612 megahertz emissions. Maybe really so. I didn't observe the star in 1612 megahertz because I expected their peaks less than one for to 20-meter dish in Green Bank. This is too weak and needs very long observations, and these observations will be too expensive in credits. But 67 megahertz line is well observed with peak up to 15 Yansky. Minimal detectable peak flux density is about 3 Yansky for 400 seconds. And it's now in my collection of observed star in with main lines is Canis Majoris, Iris 17411 minus 3154. Also interesting star Iris 17004 minus 4190. And this is 3 stars and two fresh observations of star V669 case in observed in two lines, and Iris 07399 minus 1435 Rotanek nebula observed only in 1667 megahertz line. Now five red giant stars in my collections. Also, I note that ChatGPT can generate interesting review, but much depends on the questions you submit, and criticism and skepticism with ChatGPT always appropriate. Thanks. If some questions, I will be glad.
Any questions for Dmitri? Dmitri is always exploring new worlds, new objects with new methods. Dmitri, great work. Thank you. We appreciate your
Oh,
crisp and clear presentations. And it's
I had
great
a
that it
brief
gets
question.
recorded so we can come on back and figure this out. I hear a question.
Yeah, I have a brief question, Dmitri. This is Adrian. Are you planning on maybe going back and looking at some of these observations and to see if you're catching some variability in these hydroxyl emissions?
Yes, Adrian. I I have some stars in this already observed can be very interesting in observations of variability, especially uh, especially Iris 1705 minus 4119, because early observations in 90s uh, showed uh, mm, uh, we observed 1667 megahertz line, but I didn't observe it, and this star is very interesting. I think that is I don't have some estimations for now, some estimation for its periodicity, but I I'm preparing, I'm thinking to repeat observations of the star in in the next several months, up to half of a year, and maybe later, uh, for to observe 6067 megahertz line. It can appear again, and I could expect it. For other stars, variability is not too much, but can be observed too. And also I hope to find any interesting stars with main lines. I hope these 5 stars in my collections is not this is not final in my collection. I hope to find other stars with main lines.
Excellent. Thank you very much, Dmitri. I'm working down through
Oh, thank you,
non-US
thank you.
participants. I spoke of Wolfgang next. Wolfgang, what's going on?
Yeah, I think I mentioned in the Drake's launch 2 weeks ago that we are working on a solar polarimeter where we're trying to see whether the radiation from the sun becomes polarized during flares. So that's the scientific motivation. We made some steps last weekend where we verified the software. We made some steps forward this weekend, just today, where we installed a couple of things on the hardware side. So I'm hoping we get operational there in maybe a few weeks from now, maybe 2 or 3 weeks. And of course, it will a while until we have some results. It's a fairly simple experiment where we just have a antenna looking in southern direction with two pickups for the two linear polarizations, which we feed into a dual channel software-defined radio. And now we do the calculations to come up with the parameters of the polarization. So this is a new activity essentially compared to the other things that we're doing. I just have a quick comment on the presentation, the question about the variability. There are some links given in the chat. In the meantime, we're doing quite some extensive work on the observation of OH masers and their long-term variability. And the link is, that's you'll find that in the chat. Then I have because I think Eduard will talk after me. I just have a quick message to him. He sent me an email this morning about potential frequency variations in Westerholt 49. I don't have a current observation on that. The last one is from August, but I made a note that on the next occasion, which could be as early as next week, I can do an observation of Westerholt 49 and then see whether we see the same kind of frequency shift in the strongest line. So I guess that's all from my side at the moment. If there are any questions, I'm happy to answer.
Can I ask you a question, Wolfgang?
Sure.
Which is what software are you using for this?
It's essentially
and what SDR?
It's a B210 that we're using, Atos B210. So that's a dual channel device. And essentially, we're picking up the IQ streams from that SDR, and then we do straightforward calculation in essentially in the software. It's essentially taking the IQ signals from both the polarization. So we have two IQ streams. Then we just do the calculation to get the Stokes parameters.
Sorry, so is this software you've written yourself or something that you've downloaded from somewhere?
It's partially done by Thomas Telkamp, who did the software for the streaming of the IQ data from the B210 into a stream, and then we wrote the software to do the evaluation of the IQ stream.
Okay, thanks.
Thank you, Wolfgang. Wolfgang's in Germany. We now go to another non-US, which is Eduard in Netherlands. And then I'll ask for other non-US, and we'll just start working our way down the list. Eduard, what's new?
Hello, hello. Can you hear me?
Sounds good.
Good. So, yeah, I've been quite busy actually, making the most out of my unemployment. Yeah, there's a couple things going on. So I just, about 2 weeks ago already, I disassembled the 3-meter dish because the weather has been quite bad recently. I also posted a new video on my channel about observations of Cassiopeia. So if you haven't seen that and you are interested, you can find that. There's a new video coming up soon. I just shot it today on the 1-meter dish, so expect some activity over there as well. I'm also going to do 2 presentations for radio astronomy outreach, basically. One at my local astronomy club, which will be more of like a general introduction in the topic of radio astronomy and the radio sky. And then the second one will be at a sort of like a small amateur astronomy convention here in the Netherlands. And I'll be giving a presentation on my observations of galaxies at 21 centimeters. So it's quite a bit going on. And in the meantime, I'm also still running some observation projects, so I'm really busy. I actually do have some slides to share, so let me share my screen. Okay, can you all see this? I'll put it in presentation mode.
I see it now. Rather black.
Great.
We see the little guys on the left. Oh, even big. Great.
So I've been quite busy doing some observations this weekend of some water masers, in particular Westerhout 49 and Westerhout 75. So Westerhout 49 is one source that I've been basically tracking for well over 3 years now. So I'm trying to. It's the brightest water maser in the sky, and I'm trying to do a observation at least once every 1 or 2 months to track its variability. So something interesting seems to be going on at Westerhout 49. I'll get to that in a minute. And I also encountered some problems with the frequency or maybe the velocity correction, the VLSR correction, which was also mentioned already by Wolfgang. So here's my spectrum of Westerhout 49. So this is a water maser located in a star-forming region, or it's actually like a cluster of water masers. It's just not one. It's not just one single source. It is actually a whole group of these water maser clouds, and they're moving at different velocities relative to us. So we see them at different red and blue shifts. But in general, as you can see here, there's sort of a main cluster around 0 kilometers per second. So that's the one I'm most interested in because that's usually where most of the activity happens. And occasionally, I'm also observing taking a spectrum at more higher red and blue shifts. So because there's also some activity there as well. So you can see here, I actually had to make 3 different spectra because, well, the 5 megahertz of bandwidth of my SDR doesn't cover the entire width of the spectrum. Can actually extend a little bit beyond this even. But you can see there's some activity as well at around minus 70 kilometers per second, and then there's something at plus 65 kilometers per second as well. Oh yeah, by the way, so the central part, I integrated that for about an hour, and then the red and blue shifted parts, I only spent about 20 minutes, because otherwise, yeah, it would take a very long time if I want to spend like an hour on all of these parts. But that's why the amount of noise in the red and blue shifted parts is a bit higher. So comparing this to my earlier observations from this year, so you can see that there seems to be like a slight shift in the velocity of around 0.8 kilometers per second. So, and it's not just in one line, but it seems to be like that all the features in the spectrum, or essentially the whole spectrum, seems to be shifted by 0.8 kilometers per second. And I've never seen this before, so I think there might be something wrong with either the LSR velocity correction, or maybe there's something wrong with my reference signal source. So yeah, one particular problem which I had to solve with my water maser setup is that I'm using a LNB that doesn't have a very stable local oscillator. So it can drift around a little bit in frequency. So, and the way I deal with that is that I've made a reference signal source using a DO-Botna GPS DO. So that's emitting a very faint but detectable signal at a specific frequency near 22.2 gigahertz. So I just place that somewhere like at the edge of my spectrum, and then I can use that reference signal to correct for the frequency drifting afterwards. But yeah, something seems to be off with that currently. And yeah, as I said, this hasn't happened before, so yeah, maybe something went wrong with the reference signal source with the GPS DO, or maybe there's some other problem with the way that I calculate, or that I derive the LSR correction. Anyway, so here's the same plot essentially as the last one. So, but here I shifted the velocity of the most recent spectrum from last Friday by 0.8 kilometers per second. So it's lined up with all the other spectra from earlier. So this is just eyeballing it, so it's not very accurate, of course, but yeah, now we should be able to see a little bit more clearly what's going on here. So if you look at this spectrum, there's sort of like two groups of features that are quite prominent. So there's a group at around minus 10 to minus 4 kilometers per second, and there's a stronger cluster around yeah, essentially around plus 5 to plus 15 kilometers per second. And if you compare those two, so back in the summer, so in July, August, you can see that this peak at 7 kilometers per second was not very strong yet. And then in the later spectra from September, and now from yeah, last Friday, you can see that it seems to be increasing in brightness. But of course, these spectra are all like, they aren't calibrated, so it could also be due to just some random variation in maybe some pointing errors, or random variation in the amount of atmospheric absorption. However, if you look at the other cluster of features, around minus 10 to minus 4 kilometers per second, you can see there are some changes, some features that are getting brighter and weaker, but overall the intensity of this group has remained more or less similar. So yeah, compared to the other group. So yeah, could be that there's something interesting going on with this new strong feature at 7 to 10 kilometers per second. So yeah, if we look at the broader picture of like all my spectra that I collected since beginning this project. So starting in 2022, you can see that there was quite a bit of activity early on in 2022 and 2023. You can see some flares over here consecutively at +5 and then at -5 and finally at -10 kilometers per second. Then after that, the source remained relatively quiet for a while. So of course there was still like all sorts of variability going on, but no features that were getting exceptionally strong with respect to the other features. And this new feature, which appears to be brightening, seems to have appeared sometime between July and September of 2024. So yeah, this feature has been around. This feature at 7 kilometers per second has been around for a while, and now it seems to be getting brighter. So it will be interesting to track this in the future, further in the future, see where this is going. Anyway, so I also did some observations of Westerhout 75. So this is one of these other water maser sources. So I do sometimes observe some of these other sources, but it's much less frequent than Westerhout 49. So this was the first time since last summer that I observed Westerhout 75. So as you can see, integration time 160 minutes. You can see a nice peak at 11 kilometers per second. Maybe some weaker feature at +7 kilometers per second. So if we compare that to my earlier spectra from last summer, you can see again there is a deviation in the velocity. So I'm pretty convinced that there's just something going wrong in my frequency or LSR correction somehow. So again, if we just line that up manually with the earlier spectra to compare, we can see that there seems to be some variation in the intensity. So it seems like the main feature was only half as bright. I can't actually see. Yeah. Oh, this was July 4th. But here it's a lot more difficult to tell actually if it's an actual variation intrinsic to the source or if it's just like some pointing error or maybe atmospheric absorption differences, because there's only one very strong feature here. We can't do like the same as Westerhout 49 where we can actually compare to other features in the spectrum. So it's a bit difficult to tell what's actually going on here. But anyway, interesting to see nonetheless. So that was it for today. And if there are any questions, please ask.
Magnificent,
Eduard,
Eduard. Go ahead.
Questions, little questions about atmospheric absorption. Do you make some corrections for atmospheric absorptions for observed line? And if so, please the details of atmospheric the details of corrections for atmospheric absorption.
Actually, no. These are just the data as is. So I don't do any corrections or even calibration because, well, I don't even have like a reliable calibration source at the moment. Because like all the typical like broadband sources that you would try to observe with a radio telescope to do like calibration are just way too faint at 22 gigahertz to detect with my tiny 1 meter dish. So yeah, it's really a lot of guesswork actually. So
maybe I just have a quick comment on Westerhout 49 and its long-term variability. Let me show briefly one thing. So this is a comparison of Westerhout 49 from January 2019, which is the red curve, and November 2024. just shows how dramatic things change over a longer period of time. So it's a completely different spectrum. And as you continue, and as also we continue observing these sources, we'll see all sorts of variability. And as far as the frequency is concerned, I'll do a test measurement hopefully next week on Westerhout 49 to see whether there's any shift in the frequency recently.
Okay, thanks. Great. Yeah, I think it's just an error on my side, the frequency deviation thing. But maybe Wolfgang, we can coordinate this a bit. So I can also try to set up the dish again. It's not that much effort. So maybe we can coordinate some sort of observation simultaneously, or at least like close together in time as possible.
Yep. Okay. We'll stay in touch on that.
Great.
Yeah, Edward, this is Adrian. I'd like to propose a hypothesis as to your frequency problems. Let me ask you a question. Does the Bodnar GPSO have a lock indicator for GPS signals?
Yes.
So have you perhaps noticed that perhaps at least in brief periods of time, maybe the GPSO has lost GPS lock?
I have not, but I can check.
And the reason I'm saying that is because I think it's been pretty well documented in recent, over the last quite a number of months, that there have been quite a number of incidents where GPS service has been curtailed due to perhaps interference or jamming over Europe. And there's been some incidents where that has occurred. And so my hypothesis is that if you briefly lose lock, or even just the number of satellites that is picking up, you lose the accuracy of the signal. And perhaps then the oscillator then just drifts just a little bit and it grabs on against its lock. And you're seeing these frequency changes due to unstable GPS synchronization. Just a thought.
Okay, yeah, thanks. That's something I could look into. I do also plan to do some tests to see what's going on with the, or if it could also be just that my Leo Bodnar is somehow broken. I don't know. So it's at least the most suspect component at this point.
Yeah, well, yeah. I guess it could have some problems with the face lock on the oscillator.
Yeah, I don't know. We'll figure it out. But thanks.
Anyway, great observations. Very interesting. Thank you.
Thank you, folks. Marvelous presentations, and they call you amateurs too. Amazing. Anybody else outside the U.S.? I want to respect different time zones if you're up early or up late.
I guess I'm here, Ted.
Oh, pardon me, of course. Andy, I talk with you so often, I think of you next door. Andy, what have you been busy with?
Oh, well, I appreciate that everyone's trying to get on. So today I've only got one slide to show. So I'm just going to pull that up and it'll only take a second or two. For many people, will say this is just obvious, but I just think it's quite nice to have actually demonstrated it myself. People here will remember that there has been discussion on the mailing list and perhaps a little bit in these meetings about the idea of having two orthogonal probes on one of my Cantana waveguide on the 150 centimeter solar cooker scope. So you may remember I showed this picture before, before Wolfgang shouts, yes, I know we discussed it and decided not to do this. But it's the picture I managed to find tonight just to show the Cantana and also to show the two orthogonal probes, i.e. at 90 degrees to each other. They're the same length as each other and the same distance from the bottom of the can. So the idea is they both pick up hydrogen line and then they'll feed through to whatever I'm using as a receiver and software, and we can compare the traces at polarized to each other. The original idea was I'd be able to combine them, which is what this lot was about. Then after discussion, the conclusion was that this was potentially dangerous, this idea of having a phasing cable. There might be some feedback between one and the other. So just to say I'm not doing that. The two feeds go to two independent receiving systems, both with an RTL SDR on them and running Ezra. So I collected the data on that, and as I say, I haven't got very much to show. It's just the result of one drift scan here. And not surprisingly, given what we know from professional data, they show pretty much exactly the same thing, which is really, so you might say, so what? Well, the answer is it's just nice, I feel, to be able to show that there's no meaningful overall polarization in the Milky Way data that we receive. Any comments? Well, please.
Yeah, I was actually wondering, Andy, so are you measuring continuum here?
It's 150 centimeters. You have to explain to me what do you mean by continuum rather than straight line. It's basically it's at 1,420 megahertz coming through the antenna. It's got a new elec on it, and then it's got a receiver and comes through Ezra.
Yeah, I was wondering. So the continuum that I mean with continuum, I mean like basically the broadband noise. So outside the hydrogen line, because I noticed that the map you are plotting on that's like a continuum survey. It shows the broadband noise emission in the sky. So I was wondering, like, are you measuring this or are you measuring hydrogen line?
Well, I'm measuring. No, that's just what Ezra plots things on. My data is the red plot, the red dotted.
Okay, but that's basically
that's
the
hydrogen line.
The intensity of the hydrogen line.
Yeah, at least as presented after it's gone through a new elec, which is whatever it is, plus or minus 50 megahertz. But I mean, I've used a nano VNA to tune the monopoles, so there will be an element of, I suppose, specificity about it.
Okay, yeah, I was just wondering if you're like just looking at like the intensity of the hydrogen line or the intensity of the background, basically the background noise.
No, intensity of the hydrogen line.
Oh, okay,
so,
okay.
So the idea was, again, you know, please tell me it doesn't work. I don't mind. It's as you probably noticed, I don't really understand what I'm doing. I keep saying this to people. People don't believe me, but I don't really. So what I'm trying to do is pick up polarized radio waves into 90 degrees to each other, and then demonstrate whether there's a meaningful difference between the two of them. I mean, obviously within the context of my equipment.
Yeah, I was just wondering what the plot was showing. Never mind. So, but now I understand. I think. Okay, thanks.
Not very much is probably the answer to the question. I don't mind. Hey, so, Wolfgang, what do you think?
I think the way I understand that works is it's a hydrogen line. So also, since you're using a antenna as the receiving element, I don't think you would see much from the continuum background signal. Of course, what you could try is to shift the center frequency off from the hydrogen line, maybe to go to 14, 18 megahertz. So you're outside of the band of the hydrogen line, and then see whether you can see some structure there. But I don't think that is the case with a very, very wide opening angle of a antenna. The other comment that I have, if your antenna is exactly the kind of thing that we're using for our solar polarization, so you could do the same thing.
Right. I mean, yeah, it's a great idea. Just turn it upside down. Just to say, the antenna itself is not aimed at the sky. The antenna is reversed and aimed straight down to the center of the dish.
Okay. That's right. Yeah.
Yeah.
I have a comment. Well, you guys are looking at two linear polarizations, either vertical or horizontal, which is one possibility. But you're also missing out two other possibilities of polarization that you would not be able to detect with your antenna system. And that is if the actual signal was circularly polarized, in which case, if it were either right-handed or left-handed circularly polarized, you would not be able to see any difference between your two monopoles. They'd be seeing the same pretty much fraction of the signal. So in order to do that, you would have to either phase them in some way or use a helical antenna, which would then you'd have either a left-hand twist or a right-hand twist that would then be specific for that particular circular polarization. Now, again, we don't expect circular polarization from the hydrogen line, so you'd probably see the same thing. But I just wanted to point out that there's two other polarizations that are not visible with the Cantena system. And I have one question, Andy, about the Cantena that you built. Are those end connectors that you use on the sides?
Sorry, what do you mean by that question?
The actual plug that you're drilling into the side of the can. Do you know what type of connector that is? It's not an SMA, right? It looks a lot larger than an SMA.
Oh, it's a N type.
N type. Okay, that's what I was thinking. Yeah. All right. Anyway, that's it. Yeah.
I have a quick comment on the comment. If you do, actually, if you do it the right way, that is to do a phased correlation, you can measure at the same time both linear and circular with this kind of arrangement. That's exactly what we do in our polarimeter. So we are taking IQ data from both of the antennas, and then we do the calculation. We get the full Stokes parameters. So we measure both polarizations by that way. And actually, we have tested it just to make sure that our setup works. So we put in a test signal, which was linear polarized. So we detected the linear polarization and the polarization angle. And then we took a different antenna as the source, which is a circular polarized signal then, and we detect the circular polarization. So that's a way to do it.
That's correct.
Wolfgang,
well, that's what
when you were saying, sorry, forgive me. Sorry, Adrian, carry on.
No, I was just going to say that's exactly what I was referring to, the phasing. But if you just do the straight out single monopole detection, then unless you phase the two signals from the two monopoles, then you wouldn't be able to see the circular polarization.
Yeah, you need correct. You need to phase it. Yeah.
Yeah, that's what I meant. Yeah, right.
So Wolfgang, when you said about doing the sun, so are you just saying that I could take my antenna, turn it in the other direction, and point it at the sun, and then see what sort of signal I get from that? Is that what you're suggesting, or is it more complicated than that?
No, it's. I mean, you can do a very simple experiment by pointing this antenna somehow in the southern direction, roughly at the elevation where you expect the sun, but it doesn't really matter how exactly you do that. And then you will see a daily signal. So the signal level will rise as the sun rises, and then it will increase as it further gets into the beam. You will typically get the highest signal when the sun is highest in the southern part, and then it will decline. So the Canada has a very, very wide opening angle. So it actually starts seeing the sun when at sunrise and disappears at sunset.
Okay, yeah, thanks very much to both of you.
Well, thank you. Andy, do you have another slide to show that we were from our experiment we've been working on?
Oh,
ready.
Okay.
We'll do that right now, since you're here.
Wait a minute. So give me just a second. Do you want to do the next person? Then I'll find it, and then you come back to me after the next person.
That'll work out just fine too. Anybody else from outside the U.S. just to recognize their time zones here?
I could make a little contribution. It's Mark here in
Hi, Mark.
UK. Am I coming through clear?
We hear you fine.
Yeah, because I'm going without headphones this week. If you remember, I'll share my screen. Is that coming through? Can you see my screen?
I don't see your screen, but I have so many things on top of
Screen
mine.
2.
No, it's not coming through yet.
Ah, that's looking better. Coming up.
Okay.
There we go.
Yeah,
I see a largely blue screen.
Okay, going back in history, for those of you who are not aware, I'm a beginner. I was following Wolfgang's advice for beginners, observing the hydrogen line. So that was my system, the Noelec antenna. the Sawbird LNA filter and the NES SDR version 5 SDR USB cable and an old ThinkPad. And from that setup, if you remember, I got this sort of not very impressive result. I'll just play it. Oh, sorry. Hold on, that one. Yeah. So we can see the hydrogen bump there, and then it's all noise. And then I think about 40 odd seconds, there's another hydrogen bump when it goes back in the beam.
So we were thinking your neighborhood had RFI noise. What's
Yeah,
been
yeah.
happening since then?
I'm going to show you in a second. I'm just just trying to emphasize. Right, it's coming now. So it's going. It does go quiet. There, it's quiet, and now the hydrogen bumps appeared again. Okay, so that's where I left off. And then Adrian and Wendy, they suggested, or several people suggested, I try using my system with just a 50 ohm termination to see what kind of noise there is around me if it's coming from the system. So here is this is with a 50 ohm termination for 24 hours. I speed it up. It should be about 20 seconds. This, I don't want to torture you. So that's it. So I think you'd agree from this result shows that my system is fairly noise free. So the noise is definitely coming from the surroundings. Would people agree with that?
Absolutely.
Right. So there's my answer. I have to do the observation in a kind of noise-free zone. My question is, when I want to do a drift scan, I've got to do the full 24 hours, or I can't use those plots with EasyCon. Is that right?
Ezra will accept any chunk of time you can. For example, we could cut out the noisy parts that have RFI sample by sample in time and discard them or ignore them.
Yeah.
And the same is true. We can start gluing other data files that are much shorter than 24 hours.
Hmm. Yeah.
Mark, can I ask you, your original video that you showed there, can you show that again? The one that showed the data?
This thing, oh, it's still open, isn't it? You want me to play it?
Yeah, as you did a second ago, just play it again.
If you want me to stop somewhere, tell me. It's about around about here, 40 seconds. It comes back into the beam.
But yeah. So if you sort of, I mean, earlier on, I saw a bit where it was obviously some Milky Way coming through.
So it's
I can't remember where it was now.
There. Oops.
Yeah, there. So you stop there. Right. So
I tried to stop it, and the screen's gone blank.
Yeah, fine, but we've seen it. So you are picking up. You're picking up hydrogen.
Yes.
So what are you actually worried about?
That I can't do a scan for 24 hours without all this garbage. I just
get the garbage. Okay, you get the garbage, but Ezra successfully removes most of the garbage.
It can't remove all that stuff, surely. This is just catastrophic. I can understand a few spikes. Huh?
Well, we can identify where it's bad and simply have those be ignored. We can talk more about that by email.
Yeah. Okay, but my intention is now to go to this quiet zone in my little allotment and I do a 24-hour run there.
Okay.
So
Even 12 hours here, 3 hours there, we can glue them all together. We don't expect much to be changing out in space, so every
no,
24 hours we
okay,
get a new image, and
all
those can
right.
be glued together. More
Yeah.
samples are better, of course, but
So that's all I've got to say at the moment. Sorry, nothing so glamorous as the other guys.
so often it comes down to we always need more data. That's the cry.
Yeah, yeah.
Thank you, Mark. Pre-
Okay,
keep
no
keep
problem.
working on it. You're coming up with success here,
Yeah, I spend a lot of time with Chat GTP
and you're learning a lot,
these
I
days.
must say. So this is good.
Okay, thank you.
Um,
You can switch me off.
maybe one thing that you could try, maybe if that helps, is if you just point the antenna in a bit of a different direction. I also have some issues with interference at my location. Not as bad, but I mean I'm looking for way fainter stuff than hydrogen line. And I noticed that it really makes quite a difference where in the sky I point my antenna. So some directions are really bad, and some
Yeah,
directions I see almost none. So apparently, like there is some source of interference in my local area, and it's being picked up via one of the side lobes of the antenna.
I,
So
I've tried. I've tried screening the back of the antenna with a mesh. I pointed it in towards the southern meridian. I pointed it the zenith. I pointed it north. I tried Alex Pettit's umbrella. That picked up the hydrogen signal quite well, but
hmm,
it's also full of noise again.
hmm,
I mean, my neighbour's got a what's it called? Heat pump. Um, Incredible number of security cameras all over the place. I think I'm just unfortunately in a very electrically noisy location here. By the way, Eduard, I wanted to ask you when you did your was it a water maser observation you showed tonight?
yeah,
Yeah, and I noticed your 1 meter dish was on an equatorial mount.
yes.
Yeah. Over what time period did you make your observation?
So I mentioned the integration time. So on West Route 49, I did about an hour, like on the main part.
Okay. Well, I just wondered
So
because your dish was located next to a wall, so
yes,
you're not panning the whole sky. You're it's a small window of the sky.
no, I'm just tracking it for like an hour or so.
Right,
Yeah. So I just wait until like the source is like away from the wall on the roof, and then I can start tracking it. So usually, like when it's just past the south meridian, I can start my observations and then just continue as long
okay.
as needed. But I don't want to observe when they're too low because, of course, there's also a bunch of water in our own atmosphere. And if you're looking like at a very low angle,
Yeah,
so if the source is very low above the horizon, then you get a lot of absorption. You get a lot
right.
of losses.
I watched your video tonight on the Cassiopeia A observation, and there was another one where you showed your 3 meter dish, um, sort of introduction of how you're doing observations with AirSpy, etc.
Yeah.
And I noticed you also have a lot of um, buildings around you, so you're in a sort of suburban location.
Yes.
Uh, have you done 24-hour drift scans of Milky Way?
Yes, I have. Well, not full 24 hours because I usually don't record that long. But I have done some very long, like 12 plus hour drift scans. Um, and usually what I notice, so I'm like, my location is at the very edge of a village. So I'm kind of lucky in that regard. So there is some buildings around me, but um, just like outside of my backyard across the street, there's just fields and polders and no
Mm.
buildings anymore. Um, But what I noticed is that I do have some interference in the daytime, and then at night it shuts mostly off, but not always. So sometimes I also get some interference at night, but it's usually not too bad. But it depends. Like if when I'm doing these continuum drift scans, for example, Cassiopeia A, that's very sensitive to interference. So I have to be a little bit lucky. You also saw that in the video that the first drift scan it didn't look very good. So there was this sort of rise, and it's also a bit noisy.
Yeah. Okay, thank you.
Well, good luck with your observations.
Yeah.
But, well, anyway, you pretty much tried everything I've already suggested. So yeah.
Yeah. Okay, thanks. Thanks.
Thank you, Mark.
Yeah.
Can you shut the share down, or can I push a button for you?
Oh, push the button for me because I can't find it now. Got too many windows open.
Very good. I think that's the folks from out of the U.S., just to recognize their time zones. Andy, did you have one more picture?
Yes, indeed. Yes, I've got that. Let me just share.
And then I'll start working down the list alphabetically. I'm just clicking on the participants, uh, icon on the bottom of the screen and working alphabetically. But I'd like to do presentations or reports first, in case you have something to share with us. Andy's about to show us a picture, and then
Yeah,
we'll go on to that as well.
Just wanted to show something else first.
Andy was doing an experiment with new software that I tried to come up with.
Yeah.
This has easy call at the top, but with an S. What did you find?
Yeah, well, just firstly to say this. So, whatever reason, I'm having some difficulty in terms of noise here at the moment. So, that rather jiggly line up and down, either the red or the blue over there, just shows things are completely all over the place. But anyway, in spite of that, here is first sort of not quite 24 hours, about 16 hours or so. So the graph on the right lower stage side, can show us that we are managing to pick up some data as it hits the Milky Way. For some reason, the actual power difference between noise and the signal I'm picking up as it's going through the 150 centimeter dish is remarkably small. I don't know what's going on there, but this is just to show that we are, at least with this new version of software that Ted's put so much effort into writing, at least managing to successfully communicate with an RSP duo device, which is otherwise quite a difficult thing to do because of lack of software that supports it.
And that's the first SDR play that I've really gotten to work here. I'm hoping that Andy's antenna is better than mine here at home. What we see in the top right is some large positive spikes out the top. To the bottom left, I can reduce it down to that with some fancy parameters on EasyCon, the analysis software, to at least provide the picture in the top left, which kind of shows an arc of light yellow for the galactic hydrogen. We think. We don't know. I'm not quite sure where those vertical spikes come from, the positive ones. It may be an artifact of the system or the software or indeed the environment. Andy, go to the previous picture if you would. What the SDR plays allows.
Sorry, the previous picture. Wait a minute. Hold on a second. I'd have to just. Oh no, you only sent me those
That's
four.
the one. That's the one.
Yeah.
It's coming.
Give me.
Okay. This is the strange program. What's interesting is it's got a couple of lines underneath those, just above the bright blue wiggly line. It's got 3 new lines with read bin quantity. What we're actually doing is using the SDR plays 8 megabytes of bandwidth as opposed to the 2.4 megahertz of bandwidth for the RTL SDR. So that's a new challenge. My gosh, that's so many frequency bins possible. That should give us a higher resolution in frequency information. That's good. but a lot of it doesn't have hydrogen in it. So let's just take the middle part, in fact, just the middle quarter. And so the next number says where you should start. And on the left, we're actually not doing 256 dots, but freq bin quantity is set to 1024. So some new changes coming along. It takes a little more time, but it's working harder. It's not ready yet, but we're starting experiments at least. Thank you, Andy.
Yeah, pleasure.
So you guys are just using one of the two receivers out of the duo, correct?
Oh yeah. Let's start with
Have you
one.
tried? Have you tried switching to see if the other receiver is similar or you get different results?
I haven't even put in the constant to change it to the other antenna yet. It's
Okay.
available.
Just wondering.
It does get listed, and so I think we can. All of this needs to be proven in so many ways. Anyway,
And have you sorted out pretty much the LNA settings and so forth
no,
for the system for the SDR? Okay.
no, it's set to 30 gain. Is that actually a reduction of 30 gain or an amplitude of 30 gain with SDR play? They were defining things differently for a while. Maybe that's our problem. So anyway, things are coming. There's some hope. This is true for many other SDRs, such as the B210 and other things, pretty quickly, if I could get this to work. So anyway, that's the news on the Ezra front. But let's keep working to other folks. I think we're out of the U.S. Anybody else outside the U.S. Respecting your time zone? Very good. Let's move on to presentations if we can. Who's got a presentation who wants to come up here? Otherwise, I'll just start working alphabetically down the participants
I got
list.
something to show you guys really
We're up
quick.
to an hour and a half already. Pablo spoke first. Go ahead.
Let me share this here real quick. Oh, where is it? Oh, here we go. Okay, this is my system here. 2.1 meter with an I don't know, can you see it first of all?
Yes, we see it. We
Yeah.
see many pictures.
Okay, well, let's look at this picture first. This is the live view of my radio telescope in the backyard. I have a MELE quieter here in this box, an actuator here, and I needed a way to actuate this remotely, which I found, and to come up with an accurate tilt reading. So just a piece of information, that telescope is mounted on this front wheel bearing, so I can actually move the azimuth to. I got to find a motor to run it, and then I bought this, the Wit Motion inclinometer with 9 axis, but I'm only using one right now because I don't want to calibrate it. So how do I get rid of this? Okay, here we go. So if you look at the axis here, it says 0.236% degrees. Now I'm actuating the actuator. Okay, it is pretty accurate. I'm at 10 degrees now, so I can now do drift scans at every 5 degrees or 10 degrees remotely. And I'm going to implement the other 2 angles pretty soon. And as far as the LNA, you can't see it now, but it's I have one of those Discovery dishes LNA Insight antenna, and it's actually working pretty well. So it's the Wit Motion detector is $37. Stop share. That's all I have to show you.
Good. We have two requests to put in the chat. Eduard, you were talking about your YouTube channel. We'd love a link for that that you were referring to. And we just had a question here, Pablo. Can you give us a link for the actuators? I guess those are the motors, right? We had a
It's a
question
linear
on that.
actuator. Let me share the screen again and
I think of
maximize.
them for like RVs to lift up an RV or something.
Yeah, they're not expensive. I was like $60 or something like that. Everything I do
Usually
is
run
cheap.
on 12 or
Yes,
24
Pablo,
volts.
I love that. Where do you get those actuators?
Everything I get, it's either eBay or Amazon. You see the actuator here?
Uh-huh.
It's the longest one. I think that was like $100 right here. And I'm using, well, I don't know if you can see it here, a remote control. I'm trying to, there's no way that I can actually do it through the computer right now, but I'm finding a way to do it. But basically the remote control, let's see, right there. I push it, and there goes the radio telescope. And now I
What's
have
the length of that actuator? Do you know? 24, 36, 48 inches?
yeah, I think it was 48 inches.
Okay.
And this
and
whole
is
thing I
that-
created myself out of posts, and this is the axle. This is the front wheel axle right here. So you mount the pole on the axle, and now I can turn this whole thing around because I got a sprocket here. It's a bicycle sprocket, and I have a little motor here, which is not enough. I gotta get a bigger motor. I gotta get a bigger boat.
Always a
but
bigger antenna.
but see, and if I want the reading, I'm at 54 degrees right now.
Pablo,
it's
I
pretty
recall
accurate.
Pablo, I recall you described all this construction of your dish so nicely. Was that at a Sarah conference or was it just at a meeting long ago? Maybe 2, 3 years ago.
Must have been 3 years ago. This thing lay dormant for a long time. I had an oversized computer, so now I got the MELE computer, Quieter 3 inside of this box right here. And you can't see, but I mounted the detector, the inclinometer, on a piece of wood about a meter away from the dish. This is a steel dish. And the reason I did that is because this thing also has a magnetic flux, not capacitor, flux detector. And so I want it to be as far away from metal as possible so as to get an accurate reading of the heading of this whole contraption. And it actually works pretty well. Anyway, so this is all done with less than a couple $100.
So that actuator, is that a TVRO actuator that has the output, the readout?
Let me go to my history on my eBay. I don't want to take up your time. And
Just curious if you knew. Yeah.
yeah, I usually go to the history of whatever I buy and I'll find it for you. But it's not expensive.
So
It
those
wasn't
are
expensive
available
because
online.
it does not have any feedback, any
Okay,
position
all right.
feedback. So it's the cheap one.
Okay.
Because I was going to use the inclinometer, the with motion 9-axis detector, whatever they call it. So with the Discovery LNA, for some reason the Discovery LNA is fantastic. So I just attached it to the cantenna, which is the open side is looking towards is at the focal point of, I was going to say the mirror, the dish. And it's actually working really well. Now, next thing I got to do is I got to implement ESRA into this. I'm just testing little by little. I just got the standard IF average thing. But this is the control software that comes with it, with the $35 detect. What do they call
Encoder?
Inclinometer?
Yeah, it's WT901C axis vibration inclinometer, high stability accelerate. Well, here we go. You guys can read as well as I do. You went to school, I assume. There you go.
Yeah.
And it's very accurate, and it lasts a long time, even in the outdoors.
Well, this is exciting. This is cool stuff. I have great dreams of putting a wrapper around the Easy Call data collector program so that we could also give it a bunch of commands and then come back later and find that the dish went to this place for this long and took measurements and then went over here and took measurements, all kinds of things through the night, perhaps. So maybe in the future.
Yeah, I'm not going to be able to do a tracking mount with this, but I'm going to be able to reposition every few minutes if I want to do a 1 hour gathering data from a certain object. I can do that for an hour or two, just move it at a couple of degrees every 15 minutes. Since the bandwidth, the beam width, it's 6 degrees on this thing. So that should be enough to get interesting readings.
Thank
Anyway,
you, Pablo.
That's all I have for now. Thank you.
Neat stuff. Other presentations here in the US or else anywhere? Okay, I don't hear any. I'm going to start off alphabetically at the top of the participants list, at least that I have. It says, I guess, Abel. Abel, welcome. Tell us what you're up to.
Hi, everybody. Last time I was not able to be with you because I was working in Ohio related to our project. As a summary, we are working with the wow signal, and we had to go to Ohio and see the people, the volunteers that have the archives of the data there. And we were also went to the Ohio State University Library, and we got some new papers and something. So it was very exciting. And I have a long video on that, but it's 15 minutes. But I'm gonna show maybe at some other point. But I just want to focus now in the other project related to the wow signal, using the scope in a box to look for narrowband signals. And I just want to show you a summary plot. Okay, can you see here?
I see orange and black. Yep.
Okay, we are using that scope in a box basically with a RTL SDR and a Raspberry Pi for 24-hour monitor. So every day monitoring the sky, and we are using everything the same as the Ezra with Ezra. To record the data, but we are also the file that Ezra generates. We transfer that to our analysis software, which we specialize in looking for narrowband signals. So here you see in this plot the actual output of the telescope. This is the continuum, 124 channels at every second. And then here we calculate for the continuum the signal to noise ratio. That's using a curve fit just to kind of just put a straight line. But the specialty of our analysis is that then we can plot by channels using different methods. Here we see the channels, and this is the straightforward representation where you see this straight line here for all the signals that are, all signals that are continuum. But here we do some filtering, and now you see the Milky Way galaxy, the center, and the other way around. And here is we inject a sample signal, so it's a narrowband signal as an example to see. We look at, and now in the last frame we filter everything, and it's only allows us to see a narrowband signal. There's none here. But this is what we are doing, and the idea is to having many telescopes looking at at least 3 per region on the sky. so we can get and do an analysis, and just by coincidence, signal that appears in 3 telescope will be highlighted, and those that are due to R5 will be suppressed. But then we will have this, and we will look for narrowband signal for whatever. We will also look for broadband signals, so related to fast radio version, something astronomical phenomena. But this is also helpful in the terms of SETI, because we will be looking at narrowband signal with this data. So that's we are in the process now of putting other. One of our proposals was granted, so we are in the process of putting maybe 10 or 15 telescopes around the island in Puerto Rico. And then once that works, we'll share a paper that we are writing about the details of what we did and the software for others that would just want to join the network. And that's it. Thank you very much.
Sounds great. Please put a link for your program in the chat for posterity.
Abel, I had a question. This is Adrian. Was there like a 12-meter smaller telescope at the Arecibo site that was still functional?
Yes, that's true. We are putting that together just to come back to life. It has been dormant since the collapse of the telescope was in 2020, but we used that until 2023. So it was working. And then because they have a new administration, and it has been dormant since then. And then now we test it and it's working. And we'll put it back probably at early 2026 next year. We will be putting that together, and it will be used for students for science and education in Puerto Rico. So it will be also the museum will be open by early next year. I think they have a date now by January. So a museum will be for all sciences. It's not only astronomy. And so we will have that instrument. We will have those. That instrument will be for if we find anything interesting in this a network of small telescope, then we will call the big telescope and look at this area, because we will be only able to get a strong signals and a particular region, and some other telescope we need to follow up. So that's one of our resources. And now that I say that, we have a laser SETI for the SETI Institute. They have 3 or 4 observatories in the US. So they recently installed one here in Puerto Rico, in the south of Puerto Rico, because it's drier and the weather is nicer for optical. So it's a monitor. You look laser SETI, then you will see what it is. So that's another instrument, but it's in the optical.
Yeah, I think it's hilarious that you call that 12-meter a large telescope after what you had. Anyway, that's great.
My telescopes are getting smaller.
Thank you, Abel, for the update. Keep us informed.
Okay, thank you.
Calling for any reports or slideshows? Adrian, quickly, tell us what's going on.
Oh boy. Well, let's see. Not doing a lot. I did have just one slide that I could maybe show. Let's see. Let me try to get that up. Is that coming through?
I don't see anything yet.
Don't see anything yet. Okay. Okay. Well, let's see.
Oh, I see something coming. Hang on.
All right.
All right. I see a file manager. I see a blue thing.
Okay. Since everybody did such a wonderful, excellent hydroxyl maser reports earlier, I thought I'd show an old one that I had done back in 2021. And unfortunately, I had several other ones that I had done, but they're buried inside a laptop that got completely trashed by a Windows 11 update, and I've been able to rescue just this one observation. So what you're looking at is the Orion A molecular gas cloud, the hydroxyl maser. Although it says 1658 up here at the top, I was really shooting for the 1665 observation. And you can see that what this is, it's a raster scan. So unlike the other nice quantitative graphs, linear graphs showing the signal peak, this is just doing a raster scan. And I can kind of show, is that one coming through? Where you can see
Looks
the
good. Yep. Now we see many
you,
pictures, green and
okay,
red.
you on that lower left-hand corner there, you see kind of the track that the telescope made in order to generate the picture. So it's essentially a back and forth and up and down, kind of like the old raster scanning TV sets. And so you can see the generation there of the central area there, which is actually the gas cloud where the hydroxyl masers are located. And so I tried to do that, and then also 1612, and then 1612 gave me this. And you can still see right in the center a little bit of a signal, but then all that other garbage are just RFI from satellites, maybe Starlinks, maybe other ones. But you can see the amount of interference that was there, and this is in 2021. Before really the constellation had got much bigger. And I had one observation that I might be able to rescue out of that laptop if I can ever dig it out from the mess that Windows 11 made out of it. And it's like about 3 times the amount of RFI when you do the scan there at 1612. And of course, this, oh, and I failed to mention, this is with the 20 meter green bank telescope. The amount of RFI has just increased over the years. And the one I was referring to, which I don't have because it's, like I said, messed up in that laptop, was done earlier this year, and it's just like 3 or 4 times the amount of noise that you see there. And I guess those are just the tracks of the satellites as they were going by on their orbits. But anyway, I just thought I'd point that out. It's more of a qualitative sort of observation on hydroxyl masers. But
That's fun, Adrian. Thank you. That's cool. You too can use the Sarah account to access the 20 meter telescope. Check it out on the Sarah webpage.
Yeah,
Thank you,
I've actually
Adrian.
that last observation I was referring to was done from the Sarah account. This earlier observation that I was showing was from a class that the Green Bank Radio Telescope puts on every year. They call it the Single Dish School, and I think they've kind of excluded amateurs now. I was able to sneak in there back in 2021 during the middle of the pandemic. So, but I don't think it's available anymore. But it's a fantastic course online that they had, and I was very lucky to get into it. But anyway, yeah, thanks a lot for the hint.
Excellent.
And I'm trying to back out of here, Ted. You might have to push the button
Well, I
for
can
me
push
because
a button too. I'm working my
I've
way
lost
down the
mine.
participants list. Unless you have slides to show us, Dan is the next one. Dan, tell us what's going on.
Don't have anything to report. I'm just listening and learning.
That may take a while. We have so many things
Yeah,
going on.
that's okay.
Dennis, I come back to you. What's new? Thank you, Dan.
Thank you.
Dennis, I hear a voice.
Wait a second. Okay.
That's better.
Is that better?
Yeah, we hear you nicely. What's
Okay.
up?
Hey, first of all, not too much report, lots of very much needed inspiration. I really appreciate everybody's reports. I had some observations. I'm wondering about, not observations in the sky, between my ears. The scope in the box is just a repeater antenna for tuned to Wi-Fi. And I must be in a neighborhood, I'll bet I've got 20 Wi-Fis within 200, 300 yards of me, all the way around me, broadcasting totally in a big circle. So that makes me nervous. And also I have a bunch of inverters on solar panels on my roof. And I'm wondering how I'm going to filter that out. Anybody have any concepts here?
Observe at night when the inverters are shut down, and the antenna has nothing to do with Wi-Fi. It's the the pickup on it that might be a little bit broad. The antenna is just reflection. It's just a mirror. So all you have to do is just change that the feed to tune it down, tune it up or down rather to 1420. So and of course that antenna that size just has such a wide beam width that boy, anything around it is just going to be coming through. So yeah, larger is bigger, but you don't have to worry about the antenna itself. I think the and the LNA that's used normally, that Sawbird, has a built-in ceramic filter that does kind of wipe out some of the Wi-Fi, which is more at 2400 instead of 1420. So you're quite a bit away. So that filter probably works pretty well for Wi-Fi. The thing you'd have to worry more about is cell towers, because you've got cell tower bands just around 1800, 1900. So that's a lot closer to the 1420. And so that RFI from cell sites are going to be really your biggest enemy.
Yeah. Okay. Well, thank you. I'm going to hook things up and start reading it. But
We learn by doing. Yeah.
and I've still got to download an Ezra here, so got to get rolling with that too.
Very good. Send me questions. I'm all the way down to P for Preston, I think. Otherwise, we've talked to everybody.
Okay. Thank you for giving me a chance to talk, but I don't have anything to say. So thank you much.
More inspiration going on. That's great. Am I all the way down? No, we've talked to Tom before. Tyson, please tell us what's going on.
Hi. Not a whole lot. I'm just actually working on the Radio Joe stuff. We have a good setup with low noise in Maryland here, but we're just overwhelmed with the data. We don't have it hooked up to the internet, so we can't just kind of tap into the PC and pull files. So we're trying to figure out if we just do it periodically or if we try to set up some kind of a hotspot or Meshtastic or something like that. But that's about it. The other thing is I was trying to get into GNU Radio and see if somehow the signal chain could be reproduced, if there was another way to pull data off of that dual dipole array. And so I did come across this book called Practical SDR, which is all GNU Radio. It's how to use it. It's got good, signal chains in it and how to build the radios and stuff like that. I mean, it's for, beginners, but it's going to take me a while for sure. But that's just pretty much where I'm at, just sort of trying to figure out the best way to stream data off of the array right now.
Sorry, what book was that?
It's called Practical SDR. Oh, I don't know if is it coming in there? It's a little blurry.
Back by your face, better.
Sorry, there we go.
There you go.
Yeah. And it's all GNU Radio.
GNU
Radio. How to do AM, FM, nothing on radio astronomy. But
can you show that the page again?
Yeah, sure.
Practical. You need to go a little bit further back towards your face. Sorry, not that. Sorry, the front page. Who's the author?
The author is David Clark and Paul Clark.
Does it have an ISBN number that you can put in the chat?
Yeah, sure. Let me see.
That'll help everybody. Andy, you have a ongoing video cast for GNU.
Oh yes, well, there's we so there's a couple, yeah, a couple of groups if people would like to join. Just contact me and happily send you links. So one is a hydrogen line group, and we've got the next meeting tomorrow about that. And if you think, well, I don't know what I'm doing and I haven't got a hydrogen line telescope, I'm just interested, that's absolutely fine, because we have quite a few people in that group who are in that situation. And the second group we've set up, where we're even less knowledge in the group, is a GNU Radio group, where if you think you are interested in GNU Radio, but you've got no idea how to make it work or what it does, then you're at almost exactly the same knowledge level as the rest of us in the group. So please come and join us and help us to sort it out. And I'd like to make a big invite to anybody in this group who actually knows how to use GNU Radio. If you would like to come along and give us a presentation, or help us get started, we would greatly appreciate it. But both of these groups now run monthly. They're under the auspices of the British Astronomical Association, just for convenience, and the videos get posted on the BAA's YouTube website if anybody wants to have a look at them.
One website quoted one of the early pioneers of GNU Radio that he liked GNU for the first word to be pronounced, as if it was kind of new but different. Anyway, sounds great. Yeah, we're all learning together. I think for those that remain through for the full 2 hours, I've gone through the list. Have I missed anybody? Please speak up. Wow, okay. Any other comments? Otherwise, we're going to close it out. And I suppose we have an after party where we don't go on the record. Well, thank you, everybody. Keep coming back here. See you in a month for this one. Coming up, well, actually, and then 2 weeks, we have just about the darn same thing. One is supposed to be reports on how you're making measurements, and the other one is just talking all about radio astronomy, but we mix them entirely. So in 2 weeks, another one like this on what I think is a Sunday. And then, let's see, at the end of that week, maybe 6 days later, is the Australian Drake's Lounge. So keep coming and checking us out. I'll on the Sarah webpage, there is a link for forum, and you can find out about our emailing list where we all chat, even between those meetings. Thank you, everybody. See you again soon. Bye-bye.
Awesome.
Bye-bye.
Bye.
Bye.
Save the chat.
Bye. Nice meeting.